Assalamualaikum. My name is Muhammad Adam Faris Muhammad Gairi. My metric number is 241332205. Today I will present about form work. Okay, for form work, it is divided into three sections. The first is outer side, inner side, and last one is soffit side. First, I will start with the form work of slab. Okay, so the description will be a sawn timber of 38 millimeter thickness to side of the slab. The unit for this calculation is meter square. Okay, to calculate the slab, first we need to calculate the perimeter of the slab itself first. So I get 17.169 plus 17.169 plus 16.458 plus 5.597 plus 5.597 plus 8.124 plus 5.486. So the total will be 75.6 meter. And for the first column, we put 1, then slash 75.6 time with the depth of the slab, which is 0.13. Then we will get 9.83 meter square. So the quantity at the top right, we need to put as 10. The second thing of formwork that we need to calculate is for the column. So the description will be a sawn timber of 38 millimeter thickness for side vertical of column. So the unit is same as it will be meter square. Okay, the first thing we need to calculate, the first is the gate of the column itself. So the perimeter of column C1 will 2 times 0.125 and then 2.0.225. Then we will total up, we will get 0.7. And then the total of column C1 in the drawing is 28 unit. Then we need to time with 0.7 the perimeter of column, and also 3.696 is the height of the column. So we will get 77.62. And for the perimeter of column C2, we need to calculate the perimeter first, which is 4 times 0.225, we will get 0.9. Then we have total of 4 units of column C2 in the drawing. So we take the perimeter 0.9, then times with the height of the column. So we will get, and then we need to times 4. So we will get 14.26 meters square. And the last column is column C3. So we need to same as just now. We need to calculate perimeter. 2 times 0.35 and then 2 times 0.315. So the total perimeter we will get 1.33. The total unit of column C3 in the drawing is 4 unit. Then we need to times with 1.33 times with height of column, which is 3.96. Then we will get 21.07 meters square. So we need to total the 3 column that we calculated just now. Then we will get 112.95 meters square. So the quantity we need to round off to 113. For the formwork of beam, I will take one example for outer side, inner side, and soffit side. So I will not explain every pages because it will take longer for the video. So yeah. Okay, first we will start with the outer side of beam. So the description will be the sawn timber of 38 millimeter thickness to outer side of beam. So the unit is same, meter square. We will start with the beam 8 slash A dash B and 8 slash B dash A. So the length of the beam is 2.819. Then we need to add the column, which is 2 times 0.125 divided by 2. Then we will get 0.125. So we total up, we will get 2.944. Okay, so we have 2 beam. So we need to put 2 units times with the length itself, 2.94, times the depth of the beam, which is 0.3. So we will get 1.76. For the next beam, which is beam 8 slash B dash C and 8 slash C dash B. So the length for the two beam just now is it's 1.448. So we need to add the column, which is 2 times 0.125 divided by 2. Then we will get 0.125. So we total up, we will get 1.573. So the unit just now we get 2 unit of beam that have the same length. Then we need to time with 1.57 and time with the depth of the beam, which is 0.3. So we'll get 0.94 meter square. For the last beam here is beam 8 slash C dash E and 8 slash E dash C. The length is 2.743. Then we need to add the column, which is 2 times 0.125 divided by 2. We will get 0.125. Then we'll need to total up. We will get 2.868. So 2.8, we will round off to, so it will be 2.87 times 2 times 0.3. Then we will get 1.72. So we need to total up the three items here that we got. So it will be 4.42. Then we need to round off to quantity of 5 meters square. Okay, for the inner side of beam, the description will be a swan timber of 38 millimeter thickness to inner side of beam. The unit is still the same, meter square. And firstly, we start with the beam 8 slash A dash B and 8 slash B dash A. The length is 2.819, so we need to less the column. So 2 times 0.125 divided by 2, then we will get 0.125. So the answer will be 2.694. So the two beam just now we put at the left column, 2 units dash slash 2.69 total length. Then we need to time with the depth 0.3. Then we will get 1.58. And for beam 8 slash B dash C and 8 slash C dash B, the length will be 1.448. Then we'll need to less the column. 2 times 0.125 divided by 2, we will get 0.125. So the answer here will be 1.323. So we take 2 unit 2 unit of beam times with oops, I think this is some mistake here. The length is 1.32 times with the depth of the beam 0.3. Then we will get 0.79. For the last beam here is beam 8 slash C dash E, then and 8 slash E dash C. The length is 2.743. We less the column, 2 times 0.125 divided by 2. We will get 0.125. The answer will be 2.618. So we take 2 unit of beam times with 2.618 times with 0.3. Then we will get 1.57. So the total here will be 3.94. So the quantity at the top right will be 4 meters square. Okay, the last section is soffit of beam. So the description will be swan timber of 38 millimeter thickness to soffit of the beam. So we start with the beam 6 slash A dash B, 6 slash B dash A slash A, 8 slash A dash B, and 8 slash B dash A. So we will have 4 units of beam that have the same length. So the length is 2.819. So we take the 4 unit time with the length is 2.82. Then time with the depth, not the depth actually, it is the thickness of the beam, which is 0.13. Then we will get 1.47 meters square. The next beam is beam 7 slash B dash C, 7 slash C dash B, 8 slash B dash C, and 8 slash C dash B. So the length is 1.448. So we have the 4 unit of beam times with the 1.45, the length, and the thickness of beam, which is 0.13. Then we will get 0.75 meters squared. And for the last beam is beam 7A slash C dash E, 7 slash E dash C, 8 slash C dash E, and 8 slash E dash C. So the length is 2.743. So we have 4 units of beam times with the length 2.74 and times with the thickness 0.13. Then we will get 1.42 meters squared. Or actually, we have two more beams. Okay, beams 8 slash E dash F and 8 slash F dash E. So the length will be 1.219. So we have 2 units of beams. Time with the length 1.22. Then time with the thickness 0.13. Then we will get 0.32. Okay, for the last beam, beam A slash 6 dash 8, B slash 6 dash 8, C slash 6 dash 8, E slash C dash 8, and last one is F slash 6 dash 8. The length will be 4.266. So we have total of 9 units of beam time with the length, which is 4.27. They will times with the uh, thickness of beam. Then we will get 5. So we need to total 5 plus 0.32 plus 1.42 plus 0.65 plus with 1.47. Then we will get 8.96. So the quantity will be 9 meters square.
Hello, my name is Muhammad Asyari, 241-333, 410, and I will continue with column reinforcement, slab reinforcement, and lintel span reinforcement. First, let's look at the superstructure column. We analyze three density column marks C1, C2, and C3. For column C1, which was cross section of 125 mm x 225 mm, the design utilized four number of high tensile steel grade T12 as the main reinforcement bar. To calculate the compression length allowance, to calculate the net steel length, we start with gross floor to floor structural height of 3.00 meter. We then add a compression length allowance based on 14 x 12 millimeter, giving us an addition of 0.48 meter per bar, and deduct the 400 meter depth of roof beam. They bring our net bar length to 12.32 meter, translating to 0.94 kg using a unit weight of 0.88 kilogram per meter. After accounting for 21 structural mild steel grade R6 link spaced at 125 mm center to center, the total weight of C1 come to 13.92 kg. Moving to column C2, which measure 225 mm times 225 mm, it shares a identical member setup and net length calculation to C1, yielding 10.94 kg for the T12 bar. However, because the shear link are spaced wider at 150 mm center to center, it require only 18 links. This brings the total weight for C2 to 13.982 kg. Finally, column C3 is a larger structural element measuring 350 mm times 315 mm. It utilizes 6 number of 3T12 members, giving us a net member length of 18.48 meter and weight of 16.41 kilogram. Combined with 80 links of grade R6 spaced at 150 mm center to center, the total combined weight stands at 20.87 kilogram. Next, let's look at the flow system detailed in SIP RC04. The design called for a 125 mm thick solid concrete slab. The reinforcement strategy utilized mild steel grade R8 bars, serving as both main and secondary reinforcement. These are spaced uniformly at 200 mm center to center and configured structurally in both top and bottom layer across the bed area, with a total net floor area of 89.30 meter square and an engineer reinforcement unit factor of 9.48 kilogram per meter square. The total calculated mass for the set reinforcement amount to 849.56 kilogram. 46 846.56 kilogram. Finally, let's examine the cast in situ concrete lintel placed over masonry wall opening, ranging from slab 5 to slab 8. Every design consistently incorporate a minimum structural and bearing allowance of 115 mm at both ends to ensure adequate load transfer. For clear spans up to 12,000 millimeter, a 150 millimeter times 200 millimeter lintel is used. Reinforcement with two number of grade are 10 bar, totaling 1.558 kilogram. For spans up to 18,000 millimeter, the section deepened to 150 millimeter times 250 millimeter to handle the bending moment, utilizing two number of R10 bars for a total weight of 2.59 kilogram. When the clear span ratio to 2440 mm, the lintel size is increased to 150 mm times 300 mm. This structural requirement utilize both a primary layer and a secondary layer B, utilizing four number of R10 bars in total, equating to 6.876 kg. At our maximum clear span of 3050 mm, the structural load require a 150 mm times 450 mm section. Here's the main tensile reinforcement is upgraded to high tensile grade 2312 for layer A, while maintaining mild steel grade 2R10 for layer B. This result in combined reinforcement weight of 10.08 kg. Thank you.
Assalamualaikum, nama saya Aina dari Binti Kamar Azman. Sekarang saya akan tunjuk bahagian saya, iaitu bahagian konkrit untuk taking off, yang di mana bahagian konkrit mempunyai dua tempat, iaitu columns dan beams. Jadi untuk pengiraan slipshod, saya akan tunjukkan setiap satu contoh untuk columns and beams. Jadi untuk columns yang di mana concrete grade 25 in column mark C1. Jadi kolom ni adalah merupakan kolom type C1, mana panjangnya adalah 125 mm dan tingginya adalah 22.5 mm. Jadi tinggi kolom ini akan dicampurkan dengan floor level yang telah siap, iaitu akan ditambah sebanyak 0.3 meter. Untuk kolom tadi kita akan tukar kepada meter juga. Total nos untuk kolom 1 adalah 14. Jadi kita akan mendarabkan dulu area, iaitu 0.125 darab 0.225 dan 3.657 tu adalah daripada main build level akan ditolak dengan finish floor level. Jadi kita akan dapat 3.57. Jadi selepas itu kita akan darabkan dengan 14 kolom untuk C1 tadi. Jadi kita akan dapat 1.440. Seterusnya saya akan tunjuk satu contoh pengiraan beams untuk konkrit, yang di mana di central spine ataupun staircase tie beams. Jadi iaitu jadi beam ni akan dikira di corridor and staircase spine beam, yang di mana panjangnya adalah 0.225 meter dan tingginya adalah 0.3 meter. 9.5 meter itu kita akan dapat daripada melihat di drawing type A seperti yang saya tulis di slipshod. Jadi 9.5 akan didarabkan dengan 0.225 dan 0.30 dan 0.3 akan mendapat 0.64.
Assalamualaikum dan salam sejahtera. Nama saya Raja Muhammad Ashraf bin Raja Azman. Hari ini saya akan membentangkan mengenai punya bahagian, iaitu elemen pintu dan tingkap. Pertama sekali, saya akan menunjukkan drawing untuk satu rumah teres bertemu bar yang akan menunjukkan di mana kedudukan pintu dan jenis-jenis pintu dan tingkat yang akan digunakan di dalam rumah. Okey, seperti yang dilihat di dalam video ini, drawing ini, kita membuka aplikasi drawing, menunjukkan pandangan daripada sisi hadapan dan belakang bagi rumah ini. Di dalam drawing ini juga terdapat jadual yang menunjukkan jenis-jenis pintu yang digunakan dan tingkat-tingkat yang digunakan untuk membuat rumah ini. Seperti yang dilihat, terdapat 5 jenis pintu dan terdapat 9 jenis tingkat yang akan digunakan. Untuk yang seterusnya, kita akan pergi ke taking off. Untuk taking off pertama, kita akan mula daripada untuk pintu. Okay. Untuk elemen pertama iaitu pintu, pertama kami ada glass sliding door, mesolid door sama dengan atas, timber flash door, PVC toilet door dan skid door. Okey, di dalam taking off ini juga terdapat detail yang digunakan untuk membuat pintu tersebut dan membuat terdapat adjustment for opening yang akan digunakan. Kami menidak sebanyak 115 mm ketebalan dinding tersebut di dalam unit vacuum, dan kami akan juga tidak sebanyak 20 mm ketebalan semen dan pasir untuk kedua belah permukaan dinding. Unit yang digunakan untuk pengiraan pintu ini digunakan iaitu unit nose. Seterusnya ke bahagian taking off elemen tingkap pula. Okay, di sini kami mulakan jenis type tingkap iaitu type 1, type 2 sehinggalah type 9. Okey, sama seperti pintu, kami juga membuat deduction sebanyak 115 mm untuk ketebalan breakwall dan deduction sebanyak 20 mm untuk ketebalan semen pasir untuk kedua belah permukaan ini, dan unitnya sama juga iaitu nose. Dan seterusnya iaitu bahagian slitsort. Okay, slitsort elemen pertama iaitu door. Okay, di sini kami akan menunjukkan deduction bagi permukaan dinding dulu dan diikuti dengan permukaan plastik bagi kedua-dua belah permukaan dinding. Lepas itu, kami akan mengira ketinggian dan panjang untuk pintu. Seperti ini ialah sliding door, iaitu sebanyak 2428 mm dan dia punya panjang 2743 mm. Okay, kami buat sama seperti untuk pintu-pintu yang lain juga. Okey, so kita akan ke bahagian tingkap. Okay, ini tingkap type W1. Sama juga seperti yang dilakukan oleh pintu. Kami akan deduction untuk kedua-dua belah permukaan dinding, ketebalan dinding dan pasir dan semen. Dan lepas itu kami buat pengiraan tingkat berapa unit yang digunakan di dalam rumah tersebut mengikut drawing, dan kami akan kira dia punya keluasan tingkat ni, iaitu tinggi dan juga panjang. Okey, itu saja daripada saya. Okey, untuk keseluruhannya, dia slitsort dan juga take off ini penting untuk membuat BQ, quantity surveillance, untuk tahu nilai kadar yang digunakan sebelum membuat sebuah rumah. Okey, itu saja daripada saya. Terima kasih.
Assalamualaikum, my name is Naisha Mitrizan. My matric number 241JJJ426. So today I will present the cost estimation for this project based on the prepared bill of quantities. The scope of work is divided into 5 main components: concrete works, doors, windows, formwork and superstructure reinforcement. Starting with concrete work, grade 25 concrete is specified for columns C1, C2 and C3, as well as for structural beam including the standard roof beam, central spine and front porch beams. The total cost for the concrete work amount to Rm 5,700. Moving on to doors, this section covers the supply and installation of glass sliding doors, main solid timber door with top hung frames, standard timber flush doors, and PVC toilet doors. The cumulative cost for all door installation is 7,464 ringgit 80 cents. This slide details the windows and openings. The major items include powder coated aluminium frame sliding and top hung windows, single lift MS doors, and roof ventilators manufactured to specifications. The total expenditure for this section is Rm 11,332. The final component is the superstructure reinforcement. This involves steel reinforcement bars for the columns, slabs, and lintel price at a flat rate of RM3.20 per kilogram. The total amount for reinforcement work is RM2,937.60. To summarize, the total estimated construction cost for this architecture and structure element is RM34,903.16. This figure directly reflects the exact quantities and unit rate detailed across our BQ documentation. Thank you.